As a first string, it will be my care of providing you with an overview of the cascade funding mechanism and of the DIGITbrain open call process. Then Antonio Ortiz, DIGITbrain project coordinator at P&O Consultants, will give you an overview of the project. We'll go more into technical details with Professor Tamas Kiss at the University of Westminster in order to highlight which experiments and use cases we are seeking for. And we seek to finance with this open call. We'll give you a taste of what you can achieve with DIGITbrain, thanks to the witness of one of the experiments that have been running since the start of the project, which will be presented by engineering Dario Pietraroia from Italy, from TTS. And finally, we will have plenty of room for discussion in a Q&A session within which I will involve the partners which are in charge of certain aspects pertaining to the project. Just a few rules of this webinar. So basically, the message is be patient and keep your questions for the end of the webinar, or write them in the chat box. In order to be able for us to organize the answers. Of course, the meeting will be recorded and made available in the next days. So let me now tell a word on the European Commission cascade funding mechanism, because I think one of the main strengths of the project is indeed the application of this proven and well-ruled mechanism. So basically, cascade funding implies open calls run by Horizon 2020 projects. Money is therefore cascaded from the Commission to the project, and then in turn to successful participants in the open calls. It is officially called financial support third parties because third party is the legal definition of applicants. That means you who are connected with us today. But which are the reasons behind and the benefits of cascade funding? There are several ones with respect to a traditional Horizon 2020 competitive call for proposal. The first one being that application is simpler, is far simpler and shorter. It is not a secret, I think, that Horizon 2020 is usually difficult to access for SMEs and mid-caps that usually don't have a business unit dedicated to address such a challenging program. We have also a much shorter time also to receive grants. We're talking about roughly 2 months because the funding is organized by the action, in this case DIGITbrain, and that makes the evaluation process quicker and more effective. The pilots have also a shorter time to be implemented. Is basically, in our case, is 12 months against the three years and a half of Horizon 2020 action. There is no need for 3 countries participation, although we encourage strongly cross-border experiments. And finally, the thing that probably interests you the most, which is the fact that cascade funding mechanisms ensure typically from 50K to 300K of equity-free funding to SMEs, mid-caps, and digital innovation hub. Let me say that basically the only drawback that the open call have is that they are usually hard to find. So here you can find, of course, double-clicking on the logos, there are a few links that you might find useful, starting from our website, of course, which will be constantly updated with information on the open calls. You can visit the portal that aggregates all the projects falling within the I4MS, so the Innovation for Manufacturing SMEs initiative of the European Commission, or you can widen your search by visiting regularly the European Commission website on competitive calls. So talking about opportunities now, let's go in deeper into those that DIGITbrain offers with its open calls. There will be 2 open calls along the project, with which we expect to fund and support 14 innovative experiments in total. That means basically 7 for each call. The overall budget that can be cascaded is 1.4 million euros. That means 100k kilo euros per experiment. But let's see whom these open calls are dedicated to. At the helm, SMEs and mid-caps belonging to the manufacturing sector, acting as main users of the experiment themselves. At least then one other organization acting as a technical partner. Let's say the one that provides the solution to the end user and integrates it with DIGITbrain. Any of these, so ISU, value-added resellers such as engineering consultants and research organization can act as a technical partners, whereas other actors may join the consortium if justified to support the above-mentioned categories. So 2 important things to note. The first is that consortia must be made up at least by 1 end user and 1 technical partner as a bare minimum. Secondly, that all the participants shall be established in a European member state, associated countries, or in the United Kingdom. Professor Tamas Kish will better address this later on, but let me also give you some hints on the on which application experiment we are searching for. They can cover any segments in the manufacturing sector as a whole, let's say with a preference for those segments where digital technologies are generally underexploited. Application experiments are then expected to model behavior of an industrial product with the means of digital twin, and are expected to demonstrate benefits in different phases of the life cycle of such product. Finally, experiment should ensure that during the experiment execution, all the data, the models and algorithms are incorporated and validated in the DIGITbrain testbed. Let's say that within these boundaries, we are seeking for innovative use cases, and here you can find just a batch of examples which I encourage you not to consider as exhaustive. Here is the timeline for the first open call that has been launched last month, and that will stay open until the 30th of June this year. The evaluation and selection process will take 2 months, starting from the 1st of July, following which the contracting process with third parties, so with you again, will be triggered and then concluded at the end of September 2021. From there on, the selected experiment will start their journey and will run for 12 months, meaning until September 2022. But let's see more in detail what's in it for you in this window here. So up to the submission of an application. So as you can see, the process is very simple and implies the involvement of digital innovation hubs for preparing a successful proposal. And here it comes, an important point, as we want to stress that money is not the only type of support we provide to third parties, because 6 DIAGs are involved in the project with a precise mission of providing help to proposals before their submission, and then up to technical and business support along with each successful experiment execution. So each experiment consortium is strongly encouraged to contact directly its respective DIAG according to the country where they come from. In this picture, you can find a representation of the regional coverage of each DIH, which is better detailed, however, in the guide for applicants, which brings me to the next slides, because to prepare a successful application, ideally also before contacting the DIHs, you must be aware of a series of documents, or let's say of information, which are very well explained and reported in a document toolkit that you find here. You can simply click on the button and will bring you to the download, or you can jump to the OpenCall webpage of the DIGITbrain website. Let's say that the guide for applicant is your main friend here, which deals with all the information you need to know. There are more technical hints regarding the let's say the technical aspects of the DIGITbrain projects in the technical documents, and there is of course the proposal template, which is consistent with all the information that will be required on the portal, which is the next step, as you must register to the OpenCall portal that you will find at digitbrain.fundingbox.com, and which has really a very intuitive interface. You can you have to attach your experiment proposal with the template we saw before in PDF. You can, of course, upload your proposal several times, overwrite previous versions, but whatever it takes, the submission must be completed by 5 p.m. Brussels time of the 30th of June. So before leaving the floor, let me recap here some of the main points as far as the OpenCall funding structure is concerned. We said that the funding budget available is 600,000 euros for the first OpenCall, so 7 experiments are expected to be granted. But keep in mind that the maximum amount of financial support must not exceed 60,000 euros per third party, covering all the eligible costs generated during the experiment's lifetime. We're talking about direct personal cost, indirect cost with a flat rate, and subcontract, and so on and so forth, as you will clearly find in the guide for applicants. Additionally, no third party is allowed to have received more than 100,000 euros from Horizon 2020 I4MS and Smart Anything Everywhere OpenCalls, also in the past. So that's really important. As well, it's important also that you keep in mind that the maximum financial contribution from DIGITbrain will be calculated applying these reimbursement rates that you find here. So it depends if you are a non-profit legal entities. In this case, you will receive 100% of funding of the eligible costs, and 70% if you are for all the other applicants categories, let's say. All that will be, of course, ruled in a contract for carrying out the work described in the proposal, which will be signed between the applying party, the applying consortium, let's say, and DIGITbrain's cascade funding manager, and with the signatures planned for September 2021. After these boundaries, let's say, I would recall that there are other advantages beyond financial support, and I mean, because if you succeed with an application, you will have the chance to enhance the end user competitiveness and customer satisfaction, also helping developers exploring new value stream for close to market solution. We give you the opportunity of gaining new local, but also national and EU-wide visibility along the project's dissemination activities. We give you the opportunity of accessing to free business coaching and mentorship to better exploit your experiment's results. And last but not least, the opportunity of networking with industry leaders and joining a wide community while showcasing your products and services in the digital agora of the project. So from my side, that's it. I will leave the floor to Antonio Ortiz for a more clear overview of the project as a whole.
Thank you, Giacomo, for the presentation. Well, as Giacomo has just mentioned, I'm gonna give a brief introduction of the project, without going into very much into technical details that would be the role of the next panelist. So, well, let's first have a look at the DIGITbrain consortium. It's formed. We have three main categories of partners. The first one is the core and technical administrative partners. It's formed by SMEs, mid-caps and large companies, as well as universities and FTOs. Okay, this set of partners are in charge of the development and administration of the main solutions of the DIGITbrain project. Then we have the experiment partners. These are partners in the project that are performing the first wave of experiments. The second and third waves of experiments will be completed by the participants in the open calls. And then we have a network of digital innovation hubs, which covers geographically most of the European territory, in order to provide business support and coverage to not only to the experiment partners, but also to the stakeholders in the project. Well, what's about DIGITbrain? Okay, the main challenge of DIGITbrain is to enable customized industrial products and to facilitate the distributed and localized production in a cost-effective way for manufacturing SMEs. How are we doing this? Okay, by means of data, modeling, simulation, optimization, analytics, and other kinds of algorithms to extend the concept of digital twin with not only a small picture, an instant picture of the product, but with a memorizing capacity, extending to also covering the whole product lifetime. So in this sense, what we are aiming to do is to accelerate the adaptation of manufacturing and products to changing conditions. If there's any change required for the production, the idea is that the process can be changed easily. Also facilitate flexible manufacturing. So we try to strengthen competitiveness, because if there's a need of manufacture some new product or an adapted product, it will be quite easy to be adapted within DIGITbrain, and also to enable personalized manufacturing in an affordable way, both for the manufacturer and for the final customer. So the idea is to contribute to democratize the technology access for manufacturing SMEs. Well, the main objectives of the project first is to implement, of course, the DIGITalBrain concept, which is in charge of configuring, orchestrating the data, the models, the algorithms, and also the resources. Develop as well the manufacturing as a service business models, which is being implemented by the digital innovation hubs participating in the project, both as partners and as participants in the open calls. The results of the DIGITbrain project will be integrated in the Cloudifactory marketplace. So this will give an extra visibility and for the project results, and as well as for community building. We will have 3 waves of experiments: one that is being executed with partners from the project, and then 2 open calls that the first one is ongoing. And the idea is to evangelize the manufacturing communities on the benefits and the impact of this manufacturing as a service and the results of the project with a strong involvement of the digital innovation hubs. As well, Giacomo has focused in his presentation on this first open call, which will constitute the second wave of experiments, but we will have a second open call next year that in order to complete the third wave of experiments. And in parallel, during the full project duration, what we are providing is advanced technical and business support for experiment participants, and of course, performing the continuous implementation, integration, and validation of the results of the project. Well, thank you for your attention. More detailed technical information is going to be provided by Professor Tamas Kish from the University of Westminster in the next presentation. Thank you.
Thank you very much, Antonio. And I would like to then continue from the previous presentation with a little bit more details regarding the technical requirements of the platform. I'm just trying to, just 1 second. Okay, so I think that you can now see my screen. Okay, so a few details about the experiments we are going to support and a little bit more details about the technical background regarding the project. My name is Tamás Kiss. I'm a professor at the University of Westminster in London, UK, and my institution is one of the key technology partners of DIGITbrain. So this is the reason why I'm giving this particular overview and presentation. Now, regarding the overall concept of DIGITbrain, you have already seen this slide before, but I would like to go a little bit more details regarding the technology concepts and what we would like to achieve. Practically, the idea behind DIGITbrain is that we would like to model the entire life cycle of manufacturing lines or mechatronic systems or industrial products, as we call it inside the project. So these systems are typically systems which are manufacturing other products, which are responsible for the manufacturing of other products. And we would like to monitor the full life cycle of these industrial products or these manufacturing systems from cradle to grave. So that means that from the engineering table, from the design table, up until through the whole life cycle of this product to recycle it. And what we would like to do is that we would like to model the behavior of these products with digital twins and memorize what is happening inside the life cycle of an industrial product. And then with this memorization, with these semantic and intelligent capabilities, we would like to make better predictions, better reconfiguration of these manufacturing lines, and so on. So this is the major kind of focus of DIGITbrain. Now, in order to support this, there are three major expressions which you need to keep in mind, or which are very much in the focus of DIGITbrain. The first one, which I already mentioned, are industrial products. So these industrial products are mechatronic systems, manufacturing lines that are operated by manufacturing companies, and these are producing other products. So our focus is not your final end product. We would like to focus on your manufacturing line, and we would like to optimize your manufacturing line in order to produce the particular end product in the most optimized way. Now, in order to model the behavior of industrial products, we are using digital twins. So digital twins are a kind of static or dynamic representation of your manufacturing line using models which evaluate historical or actual data and which simulate the behavior of your industrial product. And this is quite widely used, so digital twins are not really new. There are digital twins used in various industries, but we would like to extend the digital twin concept with what we call the digital product brain, which memorizes all the events which are happening throughout the life cycle of your industrial product and the associated digital twins. And based on this information, providing you further support, further information, further inferencing in order to make decisions, for example, to reprogram your manufacturing line very quickly, very efficiently to deliver new types of products. So these are the three most important things which we are looking for in an experiment, and this is what should be very much the focus of an experiment. Now, regarding a little bit more of the technical capabilities of what we are offering, as said, what we would like to do is that we would like to support the execution of your digital twin applications and also the analysis of these digital twin applications in order to support the digital product brain and to support the further decision-making process. Now, at the kind of lowest level of our stack, we are using various computational resources in order to execute the digital twin applications. These can be cloud computing resources, high-performance computing resources, edge computing resources, if they are more closer to the factory floor, but these are all supporting the execution of your application. On top of this, we are differentiating between three what we call assets in DIGITbrain: models, data, and algorithm. And these are the things which are making up your digital twin, but we would like to separate these from each other. We would like to distinguish between each of these, because what we believe that an algorithm, a model which was developed for one particular purpose may be able to reuse in another context in a completely different scenario in order to support a different type of optimization, simulation, and so on. So we are separating algorithms, model, and data in order to make them reusable and in order to support the easier creation of new digital twins. The next layer is the digital product brain, and this digital product brain, as I said, is keeping track of the various digital twin instances which are representing an industrial product and memorizing the different events which are happening throughout the life cycle. And then the final layer is the digital agora or digital marketplace, where end users can access the system and where they can interact with the system, get the answers, select the applications they would like to use, and so on. This system is developed based on already existing components. So we had a previous I4MS project which was called Cloudifactoring, where we already developed the first version of this system, and we are now extending it with more DIGITbrain specific capabilities. And we would like very much the experiments to be the first users of this system, which then will be operated on a commercial level later on. And we would like both manufacturing companies and the ISVs supporting them to be the first customers of this marketplace and utilize their solutions on the marketplace. Now, a little bit more technical details, but I don't want to go to too many details in this figure, and don't be frightened off by the complexity of this, but this is our current kind of vision about the DIGITbrain platform, where you can see that on the left-hand side, we imagine that various providers can create their assets, their models, their algorithms, their data, using various tools. We call them authoring tools, which allow you to create a new simulation model, a new AI or machine learning algorithm, and so on. However, these tools are typically outside DIGITbrain, so we do not particularly support any tool, but we allow you to use practically any tool you would like to utilize in order to develop your own digital twin simulation application and so on. And then once this simulation application is developed, then you can use the DIGITbrain platform in order to execute the application on the various computing resources. And the users, the various users, end users, expert users, can access this through the digital marketplace or through the digital agora in order to interact with your application. So this is our kind of vision, which we are currently implementing, and we very much want you as the second wave of experiments to be the very first users of this, the validators of this technology. So if you are selected, you must use this technology stack because you will be one of the first end users of our technology. And we very much hope that this will be something which is 100% useful for you as well. Now, I want to finish my presentation with a very quick overview of what type of experiments we have been supporting in the first wave. And then my colleague Dario is going to explain one particular experiment which he has been participating in order to give you some kind of hint at what we expect from experiments. If you have a look at this slide, you are going to see that the range of experiments are very, very wide. And the areas, the manufacturing areas we are supporting is very diverse. So from, for example, food, clothes fabric manufacturing to agricultural robots to aluminium manufacturing, these are very, very diverse areas. What is common in each of these is that every single experiment uses digital twin technology and the digital product brain in order to improve the capabilities of their manufacturing lines of their industrial products. So it doesn't matter, to be honest, which manufacturing area you are coming from. You see that we can support any kind of manufacturing area. But what is very important is that your application focuses on improving, monitoring your manufacturing line, your industrial product, because that is the focus of the project. That is what we would like to do. Take your manufacturing line, take your industrial product, and monitor that. We very much would like to see, for example, in the second wave, even manufacturers of industrial products joining the project consortium, because we believe that those partners who are actually manufacturing these manufacturing lines are probably the ones who are the most interested in improving the efficiency of these lines. So with these words, I would like to finish my part of the presentation, and I would like to pass it on to Dario to go to details to one particular experiment. Thank you very much.
Thank you, Tamas. Good morning to everyone. I'm Dario Petraloia from TTS, and I'm illustrating experiment 5, which is the digital brain for laser cutting and forming of aluminum. So the end user, let's start from the end user. Of course, it's Gigant. Gigant is a manufacturing SME. They produce presses for work of aluminum sheets, but they also provide full plants, integrating also their own manufacturing machines with the tools, with machines from other machine tools from other manufacturers. We have mainly 3 partners in this experiment. So, which is TTS, we are the independent software vendor, Stanford Zero, and NXT. So let's start from the end user needs. So then I will illustrate you how we are solving the needs and how we take advantage of the DIGITbrain platform in solving the user needs. So we are mainly focusing on 2 phases of the production line. So the user needed the digital twin to use it into the bidding or negotiation phase. So when they were designing the line, they didn't have anything to design a tool to simulate the line even in the design phase before the line is built. Then they had the need to perform a real-time what-if analysis based on the actual plant data using a digital twin. And then they need to provide simulation services and analytics to their customer, so they can use the simulation models. So we try to solve all these needs, implementing a digital brain solution for Gigant manufacturing systems. So what did the partners do in this project? We had as technology transfer system. We used our DDD simulator platform to create a modular system to design digital twins of production lines. We have NXT control, which is it's a part of the Schneider Electric Group. They created a middleware to interface the PLCs of the plant to the DIGITbrain platform and to make them compliant with the ESC 61499 standard and to collect data with the DIGITbrain platform, and Start 4.0, which coordinated the experiment. So what we realized at the beginning was a set of modules, prototypes. You can see one of the gigant model press in this case. Then we have trimming machines and different loading sections. So these modules are realized using our simulation environment, but then can be used by the end user without any programming knowledge. So you will see these are modular drag and drop elements which can be combined, as you can see in this presentation video, to create a layout of the plant. So we are doing this in the first phase of the plant when designing it, and then after you put, as you can see, it's a tool that can be used by every person with knowledge of course, of the plant. These machines are simulated from different manufacturers. I will accelerate a little bit on the design phase, and then I will show you that we can start the simulation. Now this line is not complete, but you can see that you can have a 3D simulation of the plant, and then also you will have, more important, KPIs and results of the simulation of your production plan. So this was happening in the bidding negotiation phase. So we are still not using the platform. So we can create different layout or X layout. Why we are using, in this case, digital technologies to improve the design phase and to compare different layouts. But what happens next? The DDD model editor can export a ready DIGITbrain compatible digital twin. So we can export a simulation bundle and import it inside the DIGITbrain platform to be used in a second phase of the life of the plant. So we can interface it also with the real plant using the gateway realized by NXT control. So what did NXT control is to create a middleware with which can connect through Modbus, but it can use different technologies. It's quite hardware independent, to the PLCs of the line, and have so a standardized way through MQTT to read the plant parameters in real time and collect data on the platform. So we have different advantages. We can have distributed connectivity, so we can have a distributed shop floor. We will have all the data coming from different sources, so you can have a different distributed shop floor, flexible data, hardware independent. So how will we deploy it then into the DIGITbrain platform? So we'll have the real plan, because we are validating this experiment with a real plant, which is working in the north of Italy, in Verona. And we will have the PLCs through Modbus sending data to the CPSizer made by NXT through the Ethernet cable. Then we will have an MQTT broker, which will send data through a FireWire server. A FireWire will also be a connectivity service, which will be provided by the DIGITbrain platform for the experiment which needs it. And then that data is sent to the data which is in a containerized execution engine on the platform. So this can be used also by the customer which bought the line to simulate different production plants and try to optimize their production. So what in all this architecture, we have several advantages of having all integrate. And the main advantages are we have a standardized deployment infrastructure because, as I know, as a simulation, we work very often in simulation of industrial plant, and we know that very often it's difficult to deploy on different architectures, computers. In this case, we have a standardized deployment infrastructure. We can make new versions, and always available both to our end user and both to their customer. The possibility of integration with other simulation models, because as Tamas showed, you can have different digital twin also for the same industrial product. So maybe for the press, we could have also maybe an FEM models to test the pressing of a certain with a certain mold, and we can combine the two models and have two different descriptions of the same line. We have a distributed architecture, as I said before. We have a distributed architecture for the deployment. We are not bound to a single computer. We have computational power on demand. If you have complex simulation, you can activate, for example, more machines on the more virtual machines on the cloud platform and have more computational power only when you need it. And okay, we have a deployable infrastructure for connecting with the factory data, as I said, and a distributed shop floor architecture that can be built and have a single view on the platform. And of course, all this knowledge that we are accumulating using the digital twin, both in the design and in the usage phase of the plant, it's standardized and can be used for new version and can improve the design of new product or the improvement of new lines or reconfiguration of lines using a standardized. These are the hard advantages, of course, maybe for independent software vendors like us. There's also the possibility to have other customer acquired through the platform, because the platform can help also to lower the barrier of access to different to all the technologies that will be provided by the different independent software vendors in these projects. So thank you for your interest, and now I think it's time for the Q&A space.
Thank you very much.